I begin with foreign integrals. Just think about this problem and how do you do this? Well, you maybe know that antiderivative of this function, right? It's going to be sine arc sine x. Okay. So if you remember this, maybe get the answer right away, right? So this is going to be arc sine x plus constant, because I know the derivative of arc sine x is going to be 6. Okay, it's no problem. If you don't know this, are we able to get it? Well, when you see an integral like that, I don't like the radical, right? But remember, 1 minus sine square theta square equals cosine square theta. So if, okay, think about that. If I put the square root there, then I get cosine theta, right? But this, we assume theta is between negative pi 2 and pi 2. Otherwise, cosine theta is going to be negative. It's harder to tell whether it's part, you have plus minus cosine theta. This is good. So if I have something like a square root of 1 minus sine square theta, I can get rid of the radical. Okay. So it suggests that maybe I can try the substitution. Right? So now I have to replace everything in the denominator. Yeah. Whenever there is x, you have to replace it. It's 1 minus sine square theta, right? Now dx, you cannot just change it to theta. Dx is going to be cosine theta d theta, because the derivative of x with respect to theta is cosine theta. All right, so let's simplify. You will get cosine theta in the denominator. You also get cosine theta in the numerator. What do you get? It's just 1 d theta. Wow, it's very simple integral. Okay, this integral, of course, it's going to be theta plus c. All right, so the integral, our original integral is going to be theta plus c if x equals sine theta. But we want to express the answer in terms of x. X equals sine theta, right? If you assume at the very beginning it's pi, right? And this assumption you can invert, you can solve for it, right? Theta is going to be arc sine x. So you get the same answer. It's great, right? Suppose you don't know, suppose you don't know the derivative of arc sine x. You still get this. So that also gives me the formula. What does that mean? That also implies the derivative of arc sine x is going to be that, right? So we're gonna, we still get a formula. Even, we got this formula using the inverse function. Okay, the derivative of the inverse function formula. We get this. But now I use the substitution. You integrate this function and accidentally find out, the integral is going to be arc sine x. Then you conclude that the derivative of arc sine x is going to be 1 over the square root of 1 minus x squared. Okay, so this is a good example to begin with. All right. Now, what we can do? Yeah, let's try slightly different. Okay. What happens if it's not in the denominator? Okay. I don't remember any single function whose derivative is going to be square root of 1 minus x squared. But the above idea, okay, maybe we can use it to evaluate this integral. Okay, right? So you can try this. Let x to be sine theta. Okay, I'm going to put sine theta there. Then dx, of course, is going cosine theta d theta. Okay, so now this integral is going to square root of 1 minus sine square theta and cosine theta d theta. Okay, we're not able to simplify the integral so much, but at least I can change square root of 1 minus sine square theta to to cosine theta. So I have done the assumption theta is between pi over 2. Okay, and I think so. We can do that, because x is definite. X absolute x is less than 1. Otherwise, the square root of 1 minus x squared is not defined. So you know that x is not big. So x equals sine theta. So you can assume theta is between negative pi over 2 and positive pi over 2. So then you get cosine theta and cosine theta. Then you realize that why we have to study the integral of trigonometric functions first, right? Now we have to evaluate this integral, right? It's going to be integral cosine square theta. So we have to go ahead and integrate it, okay? We have to go ahead and integrate. So the square has to be changed to something without square, okay? So the natural idea is half of 1 plus cosine 2 theta, okay, d theta. Okay, great. Then the next step is kind of trivial. We get the first term 1/2 is 1/2 theta. The second term, I think it's 1/2. Then you have to sine 2 theta divided by 2, and constant. The question is, how can I change theta back to the x? Okay, change theta back to the x. I can do the same way for the theta, but how about sine 2 theta? Well, I know sine theta equals x, right? I know sine theta equals x. How about cosine theta? Well, we already know that cosine theta is square 1 minus sine square theta, right? So it's going to be 1 minus x squared. Okay, you know sine theta, cosine theta, you should tell sine 2 theta, right? So you get, yeah, let's rewrite it again. Okay, this is half. Sine 2 theta is going to be sine 2 sine theta cosine theta. Okay, divided by 2, so it's cancelled out. That's the first step. Then everything's fine now. Theta, arc sine x, sine theta, x, cosine theta, this. Well, so this is a pretty complicated function. I do not know its derivative is just the square root of 1 minus x squared. Okay? But now we see that if we differentiate this function, you should be able to get square root of 1 minus x squared. Okay? Because this is the entire derivative of the function, square root of 1 minus x squared. Okay, so this is a good example, right? Yeah, let's do step by step. So I'm going to put another x here. So let's go back to this. Okay, so I put x here. Okay, how do you evaluate this integral? Right? So now we learned a great idea, right? Whenever you see square root of 1 minus x squared, I can use substitution. That is called the trigonometric substitution. This is the title of the section. Okay, if you know this is a problem from that section, it's a natural idea to use a substitution. But if it's otherwise, you have to look at the function first carefully and see if any good idea to solve the problem. Let's use substitution first. Maybe that works. Right? And the theta should be between pi over 2 and positive. Okay. All right, so let's do it. So the integral of this function, it's going to be x is the sine theta, and the 1 minus x sine square theta, right? And this is a dx is going to be cosine theta d theta. Okay, that's pretty standard. So we have to simplify. I remember without x in the numerator, I know I just get a 1. Now I get sine theta. It's not too bad because the denominator here is cosine theta d theta. You cancel it out. You get integral sine theta, not too bad, right? No problem. Right? So integral cosine theta is negative. Integral sine theta is negative cosine theta plus constant. Okay. Because differential derivative of negative cosine theta is going to be sine theta. Okay. So that works. But you have to still have to change your cosine theta to sine theta. But I know cosine theta is 1 minus square root of 1 minus sine square theta. So sine square theta is just x squared. So we get down. Yeah, not too bad, right? Still only a few steps. All right. So we don't want to give you very complicated problems, but normally this is a good example for us to put on the test. Does not take too much space, a few lines, and if you get the right substitution, then you can solve the problem. The question is, if it is mixed up with other problem, how do I know I should use substitution? Well, that's just on your experience. If you did exercise and train, and you know quickly figure out the problem, right? So experience is always it's required. Whenever you're looking for a new job, they always check your resume if you have experience. The boss don't want to waste time to training unless they're really desperate. And some people that couldn't find it. Okay, they usually don't want to have experience, sort of experience. All right. So your experience also tells you maybe there. When this problem is mixed up with other problems, you look at this problem again. Okay. Maybe there's other type of substitutions you can use to solve the problem. So some problems have a unique way to solve. Some problems have multiple ways to solve. Okay. And that's also, in reality, is that if you have to solve some problems, there was always some multiple ways to solve it. You have to find the best way. Okay. So this is a problem you can solve. You can try another substitution. Let W to be 1 minus x squared. Why I see, so my experience tells me if there's x dx on the top, I can use a substitution. This type of, this is a usual substitution. Okay, so dw equals negative 2x dx. Okay. All right, so now the integral, the above integral becomes, right, this integral becomes square root w, right? And x times dx is here. So how can I change it to dw? It's negative 1/2 dw. So it's not too bad, right? It's going to be negative 1/2. Oops, erase it. So negative 1/2 w to the negative 1/2 dw. All right. I like this tablet because I can keep writing. In mathematics, you cannot type, right? You can write it quickly, take notes. Yeah. Right. So this is a, yeah. Then use the antiderivative, right? Use that as a standard formula. And plus constant. Right. So simplified, the numerator, denominator is 1/2. I think it's just negative. W to the 1/2 plus C. So what is W? W is 1 minus x squared. So that's, you get same answer. Still, it only takes like 3-4 lines. That's also a good problem. If I put the problem on the quiz, on test, and there are at least 2 different ways to solve a problem, right? And when you're at home, before you do the homework, you look at the notes because the solution is already given there. You don't need to go to math, okay? You just cover the solution to see if you can do it, okay? Then you try, and maybe you can do it by yourself, okay? Then you look at my solutions, okay? If you couldn't do it, then you have to spend 10 minutes. You have to spend 10 minutes, okay, before you look at the solution, okay? And then oh, got idea. Then you look at the next problem and still cover my solution. So you have to go through all the examples we discussed in class before you do the homework. That will save you time actually. And otherwise, you see, you look at the problems, homework problem, and you have no idea, forgot. Then you spend 15 minutes, still cannot get it, right? And then you see, eventually you spend more time, okay? So that's my suggestion. All right, what kind of problems we're going to discuss? Okay. So some problems, yes, you can have 2 different ways to solve it, right? And why we want to study this type of integrals? Okay, here's a very good applications I want to. Okay, find the area of an ellipse. Okay, ellipse is given by the equation like that. Everybody knows the formula for the area of the circle, right? And yeah, if you ask any students in the middle school, even some elementary school, yeah, the kids can tell you, hey, it's pi r squared, right? It's the radius, if you know the radius. But ellipse, the area formula for the ellipse is not mentioned. Maybe in some high school textbooks, I don't know. I never looked at high school textbook. Here, so. But yeah, very curious, right? You was wondering why there is no formula, right? Is it impossible to solve it, or is there any way can estimate it? The typical equation for ellipse, if you describe it, is like that, right? So when x equal, yeah, this will be a, this will be negative a, and that's a b, that's a negative b, yeah. Because when x equals 0, y equals plus minus b. So definitely the ellipse is uniquely determined by the number a and the b. And can we find a formula for the area of that ellipse, the region enclosed by ellipse? Now we already learned calculus 1, okay? Right? We studied calculus in calculus 1. So we know the area of the region and how to describe the region. There's 2 equal parts up above the axis or below the axis. So the area can be just the integral double of that, this part, because I can describe the region, right? as a graph, the region in the graph. So this is the y equals, and how can I describe it? It's a b square root of 1 minus x squared over a squared. Okay, you solve for y, and you get this, right? Y over b equals square root of plus minus. Minus means it's the bottom part. Plus minus 1 minus x squared over a. So the top part. So this should be the integral from negative a to positive a. And there's a function, the integral of this function. See, now you get some integral. It's pretty similar to the one we discussed. Okay? So how can I do that? I'm going to use a substitution. I let w to be x over a, for example. You can use this substitution first. Or you can, let's do one step. You don't need to worry about this. Trigonometric substitution. I can let x over a to be sine theta. Okay? So when theta equals negative pi over 2, and x is negative a, right? So x equals negative a if theta equals negative pi over 2. X equals positive a, theta equals pi over 2. Okay, this is a substitution. Theta is going to be negative pi over 2, positive pi over 2, okay? Right? So let theta changes and x value changes. So use a substitution, I can find, x is going to be a sine theta, right? So dx is going to be a cosine theta d theta. So let's find out. Here's b, square root 1 minus sine square theta, okay? And dx is a cosine theta d theta, okay? And what is the range for the theta? Theta is from negative pi over 2 to positive pi over 2. Now what do you get? You have, this will be a cosine square, right? This will be cosine theta. So you have a 2ab integral pi over 2 and pi over 2 and the cosine square theta. And everybody knows how to evaluate this integral, right? And we did it, okay? We did that. We find out the entire derivative of that function. So let's repeat this, right? You get x squared. So you get integral, and this will be twice 1 plus cosine 2 theta d theta, okay? Yeah, let's redo this problem again. All right, so you get 2ab, the entire derivative, this will be half of theta, right? And plus, I think a quarter of sine 2 theta, okay? Yeah, when you differentiate, you get this, and you get negative pi over 2 to positive pi over 2. Now, if you plug pi over 2 for theta into sine 2 theta, I think you get 0. So you can ignore the second part. The first part is just gives you pi, okay? No, it's not, half pi. Yeah. Why? Because when theta, how can I get half pi, right? Half of this minus 1/2 negative pi over 2. So you get pi over 2, right? Yeah, this difference. All right, after you cancel out, it's a surprise to me, just a times b pi. Okay? And when a equals b, you get circle. Just when a equals b equals r, and that is pi r squared. So you get grade, you get formula for the area ellipse. This is a good application of calculus. So easy now to find out the area of the of the region enclosed by the ellipse. Okay. So we can we can express the area of the ellipse in terms of A and B in part. All right, let's try different type of problems. So we did the X over this. Then how about the integral? I put the X under that. Now I can have X. I can have X squared. I'm not sure we can. Let's sometimes. Yeah. Sometimes it works, sometimes it does not work, okay? So you can put X here, right? Dx. I cannot use a substitution. Can I? 1 minus X squared related to W. But X is in the denominator, okay? Right. Now we did if turn this upside down, that's why we use we have another method, another substitution we can use. Okay. But you see it's 1 minus squared. So let's try it. Okay. You let X to be sine theta. Okay. All right. So the integral becomes, I get negative, it's 1 minus sine squared theta. Here's a sine theta, right? And the dx is going to be cosine theta d theta. Okay. So you will get cosine squared theta, sine theta, d theta. Now what? Well, there are many forms you can describe, right? One is, that's another way, people can, they just separate. This is going to be like a 1 minus sine squared, right? Then actually you get secant theta and cosecant theta. So there's a formula you can find out what is there. Otherwise you have to redo it by yourself, right? Now that's one way to do. Okay, it is going to be 1 over sine theta, and you end up with another simple. Here's the sine theta. Okay, the second part is easy. It's only the first part. Okay. Right. So if we remember how do we do the integral of 1 over sine theta, then you probably can solve the problem. Okay. So let's rewrite this again, and we have to start over. This is a plus cosine theta plus constant. Okay, so we have to focus on this 1 over sine theta. This is okay. This is a special function, cosecant theta. Okay, you can quickly find the formula at the back of the book. Okay. This is a typical function, right? What is the integral of a secant theta? What is the integral of tangent theta, right? What is the integral of sine theta, cosine theta? So secant theta, I did it in the last class, is the integral of secant theta, 1 over sine theta. But we can do the same. Okay, what I'm going to do is, I remember I said that you have to make the problem a little more complicated before you stop, because it's already simplified. But actually, we want to go back. We want to do like that. Okay? Then you use a substitution, W to be 1 cosine theta, right? You can put a negative cosine theta, the same. Okay, let's use a cosine theta. Okay, so you will get sine squared theta is 1 minus cosine squared theta. And this is sine theta, right? That's why you can use a substitution. So it's 1 minus W squared, and that is because dw is negative sine theta, so it's negative dw. Okay. Now, there is a formula for this. The integral of 1 minus w squared. Right? It's hyperbolic like a tangent, the inverse of hyperbolic tangent. Right? Do you remember that? Yes or no? No, I have no idea. What is the derivative of inverse of hyperbolic tangent? Right? So this is a in section 6 point inverse function, right? 6 point section chapter 6, yeah. It's in the section on hyperbolic tangent. Okay. Well, without doing that, we still can solve the problem. Suppose you forget the formula, right? How do you do that? That's another question. I'm trying to find the page. If you don't know the derivative of hyperbolic tangent x we from Math 165 from this semester we're using e-textbook, but I found the e-textbook is difficult to find the right page. One chapter is so many pages there. I just have there's no number I can click directly. I just want to tell you this is from section 6.7, yeah. Okay, so you can find the formula in the book. Now, if you don't have the formula, we remember it. If you don't have the formula, this is arctangent, right? If I'm correct. Okay, and plus constant. Now, you can also find it using the formula 1 minus w squared, right? Negative. It's going to be w squared minus 1. So you can also get this, okay? And you separate them, okay? Actually, you have to do the subtraction. Okay? When you do subtraction, that's 2 on the numerator. So this is the typical idea you can get, okay? Then integral on both sides gives you the integral of this will be natural log of w minus 1. Okay, and this is natural log of w plus 1. I'm sorry, this is w. Okay, and plus constant. So you can also express it in the form like that. Okay. This is actually the same as arctangent. There's another elementary formula for the inverse of arctangent w. Okay. All right, so we get the integral of this, okay? And this is either way, you know, which doesn't matter which one you want to use. And use natural log is better maybe, okay? So my formula, see, we use the several substitution right now, right? And the integral of 1 of sine theta d theta equals half of natural log. Cosine theta I think this will be the absolute value, because otherwise it's going to be negative, right? Because we are using, we are using the cosine theta for W. Okay, so that's the formula. Not too bad, right? So now we go back, okay? What we got here is we get everything cosine. So integral of this, right? Integral of this is very complicated now. It's going to be the integral of sine theta d theta plus cosine theta plus c, right? That's what we got before. Let's go back here. And then since I already have this formula, okay, then you have to replace cosine theta by x, right? And now cosine theta equals 1 minus square root of x. Right. So you put this back. Yeah, it's pretty, pretty complicated. Okay. So we are not going to continue on this type of problems. But I already discussed most of the problems related to this special trigonometric substitution. So now we're going to look at some other formulas. All right, so let's look at this integral. It's going to be x squared plus y integral, right? The only difference is 1 plus x squared. The first one we discussed is 1 minus x squared. Okay. So how can I evaluate this? Okay. X squared plus 1. If I put a radical, it's very I don't want to begin with a very complicated problem. I let them remove that square root of, let's begin with the first one. We can put x here. Yeah, let's make it a bit easy. So for this problem, okay, we have 2 different ways to solve it. First of all, you look at this function, right? There's a natural substitution you can try, because there's x on the top. Significantly changes the problem here if I put x on it. So the first method you can try is this, right? And then dw equals 2x dx. So this integral, okay, is going to be square root w, and x times dx is half of dw. Okay, so now this will be w to the negative half dw, right? So let's find out the entire derivative of that. So after you simplify it, you will get w to the 1/2, and which is going to be square root of w, right? And this, what is w? W is x squared plus what? And then you solve the problem. Okay. Right, not too bad. Now, but we also know that how to get rid of x squared plus 1, right? Inside radical. I know 1 plus tangent square theta equals secant square theta. So secant square theta is going to be part. So this is a right. And if you assume theta is between negative pi over 2 and positive pi over 2, then this is going to be secant theta if theta is between pi over 2 and positive pi over 2. Okay. So you can get rid of the radical, right, using this formula. Yeah. So now this suggests the following. Yes.
Can you not use negative sign?
Negative sine theta?
As X?
You mean substitution?
Yeah.
You cannot use sine theta because sine square theta plus 1 is not going to be something squared. Okay? Yeah, that's a problem. Yeah, we do have some formulas you can use, like we also have another one, like a hyperbolic cosine, cosine square minus hyperbolic sine square also gives you, yeah, this is a plus, okay? Hyperbolic cosine theta minus hyperbolic sine square theta. I think it's what, maybe you can use that formula because 1 plus hyperbolic sine theta is going to hyperbolic cosine theta. Okay. But you cannot use a cosine theta minus sine square theta equals 1. All right, so let's try this. So that gives us give us some good suggestion. Let's try to let x to be tangent theta. Okay. Then dx is going to be secant square theta d theta. Okay. So it's integral. Okay, let's simplify this integral. Here's tangent theta. Here's a square 1 minus tangent square theta. Dx is secant square theta d theta. Right? Maybe we can solve the problem. All right, so the numerator is going to be, denominator is going to be secant theta. But I also have square secant square here. But I cannot cancel secant theta. I get this. Okay. Tangent theta and secant theta d theta. What is the antiderivative of this? If you don't know, then you have to evaluate it using substitution. Right. But this is a derivative of secant theta. Okay. So it's going to be secant theta plus c. I have to change it back. Secant theta, I know x equals tangent theta. How can I express secant theta? But secant theta is relative to tangent theta. So it's going to be square root of 1 plus tangent square theta plus c. That's why it's 1 plus x squared plus c. So you get the same result. Okay? You use this substitution. Okay, so this is how do we solve the problem using. See, for this particular problem, we have 2 different ways to solve it. One is to use a traditional substitution or use a trigonometric substitution. But yeah, let's go back to here. So it's going to be let's without the x, okay, without the radical, okay. Without radical, how can I we're going to solve the problem. Well, I already know the formula, right? I know this is clearly is going to be the derivative of arctangent x. That's constant c, right? We already know that. Okay. But I can also use a substitution because I know, remember, right? Sine, let's try this substitution for, let's say for fun. Okay, let x to be tangent theta. Okay. Then dx is going to be secant square theta d theta. So this above integral, okay, is going to be, this is a secant square theta, right? Yeah, it's 1 plus tangent to square theta is going to be secant. Yeah, let me keep the details. Yeah, original. I'm not going to skip the steps. It's going to be tangent square theta plus 1. dx is a secant square theta d theta. But the numerator and denominator are the same. So just d theta. Okay? Because tangent square theta plus 1 equals secant square theta. And then you get theta plus c. But how can I get theta back? Arctangent x. Right? Yeah, right? So even use a substitution, you still get arctangent. This is very similar to the one integral of 1 over square root of 1 minus x squared. All right, so now we move on to the next problem. At the very beginning, I put the square root of this, right? So this time you have no choice. You have to use the substitution to try to simplify. Okay. So let's use a substitution. Let x to be tangent theta, then dx equals secant square theta d theta. Okay. So I put it into integral, and I get, and this time is square root of tangent square theta plus 1, and secant square theta. So this time I'm not able to cancel secant theta. I get secant theta in the denominator. I have an x secant square theta in the numerator, right? So that would be, so this is, but end up with secant theta d theta. That, we remember that, right? What is the integral? Something you can write down the answer right away. If you memorize the integral secant theta, then you can, you can write down the answer right away. Okay, so it's going to be integral secant theta. Okay. Integral secant theta. If you don't know that, then you have to redo the problem again. Okay, it's going to be integral of cosine theta d theta, and that's what I did, right? I multiply numerator and denominator by both by theta, cosine theta. So then you use a substitution. This is the one sine theta. Then that would be dw 1 minus w squared, and then there is a formula. Okay. Okay. So the integral of this, there's two formulas there. One is going to be hyperbolic inverse about tangent theta. Another one is, I'm not going to redo the problem again. Another one is going to be half of natural log of w plus 1, w minus 1 plus constant. So in either way, So you can choose any of that. But W is sine theta. What is theta? Right, I know the tangent theta. Okay. Yes.
How do you go from cosine to W equals sine?
How do I go? W equals. I know. I let W to be sine theta in order to evaluate this integral. Because I forgot the integral of sine secant theta. If you remember that, then just write down the answer. Okay. So otherwise, this is you have, this is standard way. Secant theta, there's only one cosine theta there. You have to multiply cosine theta by cosine theta. Then use a substitution. It becomes this. And this one, I remember the formula for the entire derivative. Okay, there's two formula. One is arctangent, inverse of arctangent, hyperbolic tangent. Okay, either way. So then you have to change to, let's use the first one. Okay, doesn't matter which one. So let's use this, and then sine theta, right? Plus c. Okay, but we use a substitution for the tangent. So how can I change back to x? Okay. How can I change it back to x? Okay. Tangent theta, okay? Tangent square theta plus 1 equals secant square theta, right? Secant is just 1 over cosine square theta. So this is a link, right? So I get x squared plus 1 equals cosine square theta. So in other words, cosine square theta is going to be 1 over. Okay? Then I can get sine theta. Sine theta is this. So it's 1 minus 1 plus x squared. And after you simplify it, you get this. All right, so what is sine theta? You have to remove you have to put a radical on both sides. If you put a radical on both sides, you have to make sure which one is positive. I think sine theta has the same sign as x. That's the reason either you both, otherwise you have plus minus. Because sine theta has the same sign as x, so that's why I just put it. Okay. Then you can put the answer here. If you don't like this expression using natural log, then you get the natural. Okay. You get the expression in terms of natural. Okay, so this is a complicated problem, actually, because you have to solve for sine theta in terms of x. Okay. So let's continue to simplify because we have another formula here, natural log, right? W is 1 plus, here's x. What is that? W, W plus minus doesn't matter, it's 1 minus W, right? Are you able to simplify this? Okay. The numerator, then you multiply the numerator and denominator both by square root of 1 minus x squared. So you actually get square root of 1 minus x squared plus x and square root of 1 plus x squared minus x. Okay. And you can continue to simplify this. Okay. You can continue to simplify this. How do you do that? You multiply the numerator and denominator by by this. This is a square, but here as a denominator, you get you multiply by square root 1 plus x squared plus x. Okay. Then the denominator is nothing but 1, because 1 plus x squared minus x squared is just 1. So all you have to get is this. You see that, right? And then take 2 out, you get absolute value of 1 plus x squared plus x. But this term is always positive. It cannot be negative. So you even don't need to put the absolute value symbol there. Okay, our final result is simple. Our final result is it. And you can check that when you differentiate, you get 1 over square x squared plus 1. Oops. I think if I change the problem a little bit, x squared minus dx. Okay. My question is, are we able to get this or not? Okay. This time, when x is larger than 1, so x larger than 1, right? I guess so. It's pretty in similar form, right? Yeah. Let's verify this. I'm gonna verify this. Let's differentiate. With respect to x. Sometimes you remember, I remember this, maybe this is a solution, right? And you don't have time to evaluate the integral. You just double check whether the derivative is going to be 1 over square x squared minus 1, okay? Then use a chain rule. You will get, right? But here, x absolute x is greater than 1, right? It cannot be. Okay. Then you differentiate the numerator. You will get, because when you give a proof, it's very similar to the above problems. So you get square of x squared minus 1. And then twice, so actually just x. Okay. Yeah, you can differentiate square of x squared minus 1. You will get x over square x over x squared minus 1. Then, after you simplify, you will get you see that cancels out. And you will get, great, you're happy. Okay. So that's the antiderivative. How do I get it? I just make a conjecture because it looks like very similar to the one square root of x squared plus 1, right? The above one, right? Then I only make changes x squared minus 1. So if I can verify the above identity directly, I should be able to, by a similar argument, I should be able to verify. this identity below that, right? So if you're able to verify this is the antiderivative, then the answer is, yeah, then you just put answer there. But you have to prove it, okay? Now, if you cannot do that, what is the natural substitution you can use? Well, the natural substitution you can use is the formula we have, okay? Remember, we get tan square theta plus 1 equals secant square theta, right? So that means tan square theta equals secant square theta minus 1. Okay, that is x squared minus, right? So this is my x squared minus, right? Right, so it's a very natural idea to use the substitution. You have to use x to be secant theta instead of tan theta. Okay? X equals secant theta. Now, if x equals secant theta, then dx, what is the derivative of secant theta? Dx is going to be derivative of secant theta. Tangent, right? Times secant theta. Right, d theta. Okay. Yeah, because this is going to be 1 over cosine square theta, then sine theta on the top. Yes. Okay. So the integral of this is going to be the integral of secant square theta minus 1. And then here is a tangent theta, secant theta d theta. Right? And the denominator, it really is going to be just tangent theta. Denominator. You end up with the same integral secant theta. Right? Integral secant theta, by the same idea we did it before, we come back to this integral secant, right? It's cosine theta d theta. All right, so you still will, use the same idea repeated, right? And then use a substitution, okay? So use substitution, you let W to be sine theta, okay? Then dW is going to be cosine theta d theta. So this is going to be 1 minus W squared dW, okay? And we end up with the same integrals. It's not surprised. And I can write down the formula. Okay, it is going to be absolute value of W minus 1, W plus 1. It's the same result. Okay. And this is going to be sine theta minus 1, sine theta plus 1, and plus constant. So what is my x? X is secant theta, okay? How can I express secant theta, sine theta in terms of x, right? Well, there's a relationship there, okay? So how can I do that? Well, that means cosine theta equals 1 of x, right? So sine theta is going to be square root 1 minus cosine square theta. Right? It's going to be 1 minus 1 over x squared. And that is going to be x squared minus 1 over x squared. That's going to be x squared over x. Okay? So sine theta has the same sign as x. So then you just plug in back and you end up with similar. Okay? Then after you simplified, you will get natural log of square x squared minus 1 plus x plus c. Okay. When x sufficient large, I think I have to put a absolute value here for this case because it could be negative. if x is negative 100, this will be negative. I have to put absolute value. I cannot remove it. It's different from the previous. So after you simplify, then you will get this this integral, and you can double check. You know, if you differentiate, you will get the square root, the 1 over square root x. Because those are the trigonometric substitution. If sometimes you can use a traditional substitution to simplify, right? And sometimes you have to use a trigonometric substitution to solve it. I know it's hard to memorize all the formulas, right? And if you can do enough exercise, okay, you're probably able to memorize those formulas, the derivative. Sometimes you can write down the integral of secant theta right away. You don't need to repeat this procedure over and over again. Okay, so you do need to know what is the integral of sine theta d theta. What is in that's this is trivial. But how about integral tan theta? How about integral secant theta? How about integral cosecant theta? Right? Okay, so if you know those formulas, then you can save time. Those are the very special functions. Okay, so integral of these functions you can memorize. You can write down these answers, a piece of paper in your notebook. Yeah, I usually have two notebooks. So one is notebook I take notes in the class. Another notebook is my summary and the key examples. Okay, so that's for the review in the future. Okay, so I suggest you have two notebooks. Okay, and then probably you don't need to take notes even in the classroom. I post all my lectures on Canvas. You just need to click and print out if you want. Yeah.
So do you want us to use the natural log method more than the log arbitrary?
Yeah. Natural log more friendly. You see, the complexity of the functions, more elementary function rather, like the polynomials, right? Radical, square root x squared plus 1. Those are what we call. That's like lives, right? This is the most simple one, like a biological cell. So the next level is trigonometric functions, then natural log functions, exponential functions. Then that's the way. How do you study, right? That's when you look at textbook you studied before, right? Then above that will be like how inverse hyperbolic tangent. Those are the correct. Those are the functions we learn in college. Okay, so you try to express your answer using the more elementary functions if possible. Okay. Yeah. And so I prefer natural than inverse function. Okay. Yeah. Natural is more. We spend more time to memorize about natural. Okay. All right. So